Hi, I was one officer primary 6 from Imi Primary School. This time we're still at ordinary differential equations. When ordinary differential equations, we're still revising the different types of methods. And in fact, right now we're still at characteristics equations. When characteristics equations, it's used for the homogeneous parts, and it has to be for constant coefficients and linear. So for this homogeneous part, we'll continue to look at what if these solutions are repeated. But I'm just going to write down first all those types of methods that we have already revised. For the first type we have used or revised is the separable differential equations. Then for the second type that we have revised is the total differentiation. Then the third type that we have revised is the integrating factor. Then the fourth type, which is what we're revising right now here, is the characteristics equation. Okay, so far we have revised these four methods. And right now we're still at characteristics equation. For this part of the characteristics equation, this is used for here all of these constant coefficients, and this part must be linear. And this keeps on adding until then this would be equal to 0. Then this part is homogeneous. But right now here, we're just mainly thinking about this case. For this case, for characteristic equation, you just change it into, here you make a substitution, just that you get lambda to the power of n, because all the other part, the e to the power, that part, they will simplify. And this is what you have. Then after all those processes of getting this lambda, you find out what is this y, this homogeneous solution. Well, for this case, you can just don't write this h because this is already homogeneous. But in some other cases, you might need to. So for this part, this first constant, but you can write this part as C1 or V1. And this just keeps on adding on, depending on this part. First of all, this characteristics equation is actually just changing from this differential equation into an algebraic equation. After you solve this algebraic equation, then you put it inside here. But this it's just this general. It just keeps on going on and on. But this last part would be this part, it goes from here. But this, you can say that it is somewhat general, but this, all these lambdas, they must be distinct. That means they must be different. This for this case. This case, they must all be different. But what if, like you can say two of them are the same? For example, these first two. What if you say lambda 1 is equal to lambda 2? And this is just if. So according to all those examples that we have done, in all those examples, we rotate with this x. But does it really have to be this x? So we'll need to verify that this is actually x. And in all those examples, this part, you can just write it as lambda 1. So right now here, I'm going to verify that this is an x. But we can just say that we don't know what is it at first. For example, we can use this. Okay, just take this example. Wait a second here. Okay, yes, we can use this example. So this example for the characteristic equation, it would be, lambda here will be a square. Okay, then this part we can factorize it, which is lambda minus a then square. That means these two roots of lambda would be a. So you can say that this root has a multiplicity of 2. Or you can just, if it is just 2, you can say like double roots. But this you can use as multiplicity. So then you get this part. You sub it inside. Then what you'll get here would be, here's your first constant. Then it's e to the power of ax. Next, c2. But this part we are not sure, so we just let it be x to the power of n. Then e to the power of ax. This first part, we're already very sure that it is right over here. So this first part, we don't need to consider about that anymore. But from here, we just let it be. Let's just say, for example, y2. So here is your y2. Well, this part is y1. Okay, we can just let it be like that. Then here you have until second derivative. First thing, find the first derivative. This part you have to be careful. There is a product rule here. Then after that, you'll find the second derivative. So we went from this part. This part you can differentiate this part, a times n times this whole thing. But here when you differentiate with this x to the power of n, they'll get another of the same thing. So at the same time, you can combine those together. So these will be what you get. Then after that, you have to set all of them inside here. So you can just write it up here. First part. So this will be your first part, as this part doesn't have to times anything. But the next, you have to times a negative to a. Then after that is times is a squared. And then all these you have to be equal to 0. So let's check which of them can cancel out. In this first part, it cannot. This part with this. Okay, so these two will cancel out. Then these two parts cancel out. Okay, so that means it's just left with this part being equal to 0. So let's check what n could be. If it's here, then n can be 0. And n minus 1, that means n can be. So at this part, what we have verified is that this x power can be 0, can be 1. So if it is 0, then it's just this constant. But if this is 1, then it's just this x. Okay, and this is what we have always used. So right now here, let me clarify things a little bit. Firstly, from this part. Well, this is actually right now here, it's just specifically for this second order. Well, if it is for this general, then there has to be going on. But this x over here, if we don't have this x, that means it's just this constant. That means it will be same as the first part. And when it is same as the first part, they will just combine. And when they combine, that means we're still missing one more. So then we just times this x as the sines, cosines. I don't think they'll be able to get this. So the most probably one is this x. Then for the next problem that you might have, is for this x to the power of n minus 2. This n over here, what we have found out is a 0 and a 1. But how is this right that you get x to the power of negative 2 or a negative 1? But actually at this part, at first, we just assume that this n is a very big number. That this n, you can take second derivative. So we just assume that you can take this second derivative. After we just try. Okay. But right now here, n, it has to be a whole number. And Why does it have to be a whole number? Because if it is, well, this whole number, when it differentiates, at last, when it gets to the power of 0, it just becomes a constant. If it is not a whole number, it differentiates, keeps on differentiating, but then it will become the denominator. Then this, when it becomes the denominator, that means it just keeps on continuing. Then that would be wrong. Okay, this is only right now here until the second derivative, which is only 2 repeated roots, or roots have a multiplicity of 2. So in the next lesson, we're going to have roots with a multiplicity of 3, or the triple root. So I think this lesson right now here, I can end it here. So if you like our videos, don't forget to subscribe to our channel. Thank you for your watching.